So now that in the previous video we had a look at how to construct a new script using plu-ts, we had a look at the interface of the script constructor. We see that we need to specify what kind of script we are building. We have native scripts and we have plu-ts script. I think we can now move to something a bit more fun and we can play a bit with native scripts. So here I have a new subfolder called native scripts, where I have prepared a bunch of native scripts we can use. The interface of a native script you can find directly going here is even better. Well, of course you can, if you want, find it over here in the plu-ts documentation. But if you go over here on the definition and click on native script to Zbor, which is this utility function that we have here, Zbor is just the serialized format of the script block. We are not really interested in that. We are only interested in what we can express with native scripts. We see that the definition of a native script looks like this, and essentially is a new union of possible interface. We can, as we said in the previous video, a script, regardless if it is a plu-ts script or a native script, all it does is enforces additional rules to the transaction. So the basic rules that the transaction must respect are that the total input of the transaction, so that includes the value of the UTXOs that we spend if we are minting new tokens. So the base rules of the transaction is that the total input is equal to the sum of the total output plus, of course, the fee. So this is the basic rule. Then, of course, there are some other rules, such as when you spend a UTXO of an address that is of a public key, of course, you need the signature of that public key in order to spend. So that is a rule as an example. But we can impose additional rules that must be respected for the transaction to be valid using scripts. That is exactly what scripts are for. And native scripts are pretty simple, as we can also see from here. There are just a bunch of actions that they can express, but most cases they are enough. One very simple case that we have also here are multisig. We'll see this in a bit. We can express multisig only using native scripts. So the action that we can describe are the request of a signature, of a specific signature, in order for the script to be valid. We can require multiple scripts to be valid, so multiple native scripts to be valid for one script to be itself valid. We can require one of many, that is what the any script stands for, of a native script, of a set of native scripts for this script any to be valid. Or we can have a combination of the two. So maybe we can specify a set of native script, but we want maybe only 2 or 3, and maybe we have 5 of native scripts. So we can require a subset of a specified set of scripts to be valid, to be accepted, in order for this to be valid. And there are also a couple of scripts to make a script stop being valid after a period of time. As an example, there is the after native script, which makes a script valid only after a given time, so a given date. So as an example, imagine you have your nephew, okay, that is very little, and you want to give him some ADA, but he's too little to manage his money. So what you do is you would do, as an example, a script all. You would require the signature of your nephew, but you want it to be valid only once it reaches the major age. So here you specify both major age of your nephew and the signature of your nephew to be requested in order to spend the fund. So this could be expressed as an example with a combination of after, all, and signature. And of course, we can also make a script being invalid after a given time. So we can use a script only up to a given date, and then this script will be invalid. In order to do that, we can use the script before. So before a given date, the script is valid, but as soon as we reach that date, we can no longer spend using this. So there are a bunch of actions that we can use, and as I said before, we have some example scripts here to use to see a bit what we can do with these. So here I'm starting with a shared script as an example. A shared script here is defined a type any and 2 signature native script. It means that either this signature or this signature is needed to spend from this script. this could turn useful. As an example, if you want to set up a shared account, that is why this is a share, I call this shared, with your friend. You want to have some shared funds, and you do trust each other, so you do not need the approvals of the others if you want to spend from this shared account. So this is what this native script is requesting. Of course, in order to spend from the script, we first of all need to fund the script. So here I'm importing this script from here, okay, and I'm constructing the address. I'm querying the UTXOs that I have on my own personal address, and of course I'm building my transaction builder so that I can build here the transaction. The transaction, I'm looking for the first UTXO that I find that has at least 12 ADA, because we want to send 10 ADA to the script address, and we need a bit more ADA to cover the transaction fee. So whatever is left after the transaction fee, we send back to the address from where we took the input. So this is a very simple transaction that we use to fund. Of course, we need to send the transaction with the private key of the UTXO that we are using as input, and then we submit the transaction, and we have here a link to have a look at the transaction on chain as soon as it is included in a block. So in order to run this script, of course, since we have two scripts, the fund and the spend Typescript file that we can run, for this particular project, we have no longer the npm run start, but instead we have npm run fund to run the fund.ts, and we have npm run spend to run the spend.ts file. So here, in order to run the fund.ts here, we need to run npm run fund here. And if I enter the command, now it will compile this Typescript. And here we see, yes, that is successfully submitted the transaction. Here we have a look at the hash of the native script. We have a look at the address that generated that script. And we have also look at the source of the script here. We see that we are requesting the signature of any of these two public keys in order to spend from this script. We also see the transaction body. We have one input as expected with more, well, in this case, 1,000-ish ADA. We have 10 ADA that are going to the address of our script. And we have the rest, minus, of course, the fee over here. We have the rest that is going back to our own address. And of course, since we have signed the transaction, we have also the signature of this public key. So if we click here, we should be able to see a transaction. Yes, and it is already included in the blockchain. And we see that, we have successfully sent 10 ADA to our script over here. So now that we have some funds in our native scripts, we can go ahead and run instead this spend.ts file. And here we see that we are once again constructing the address of the script, but this time we are querying the UTXOs that are present on the script address. Then using those UTXOs, we take the first, and in order to spend this UTXO, if you remember, I told you that we need to sign the transaction because we use public keys. When, of course, we have our own funds, we need to sign the spending of a UTXO. But since in this case we are using the script, we need also to include what is the source of the script so that the transaction builder and also the Cardano node can validate that in fact the additional rules that the script is imposing are respected. And then in this case we are signing the transaction, yes, but we are signing the transaction because the script requires it. We are not signing the transaction because we are spending one of our own input directly. We will see this also with one of the other scripts that we don't really need to sign the transaction because the script rules only needs to be respected. So in this case, our script, as we saw a moment ago, only requires one of these two signatures in order to be valid. So here we are submitting a transaction, and we should expect it to be correctly accepted by the blockchain. So here we go on the console and we write npm run spend, and now we are running spend.ts. Here we see that the transaction is also accepted, and we see that in fact we have the input from the script address, and we have the output that is going back to our own address, because here we have the change address. If you see, that is our own. We have a slightly bigger fee because we have included the script in the transaction. So the transaction is slightly bigger. If you notice, we have included the script in the witness, and in the witnesses is where the signature usually goes. And as I told you, in order to sign the transaction, the script doesn't really need to sign because it cannot. It doesn't have a public key. So what we do is we include the source of the script, and this is included in this transaction, so that then the Cardano node that looks at the transaction looks at the source code. It runs the source code. In this case, this very simple JSON. If you want, it runs the rules associated with this script and checks that are respected. In this case, it checks that there is a signature for this public key. Well, actually, this is the public key and this is the public key hash. Anyway, if we go here and open this link, we see that the transaction is included in the blockchain, and we did get, in fact, our 10 ADA back. Well, we got 9.83 because we paid some fee, but this one is going back to our own address. So now that we saw this very simple script, let me change the script that we are exporting to this multisig, just to let you see how now only signing with one signature, since here this script is requiring that, well, at least you of these two scripts are respected. So both these two signatures must be respected in order for the script to be valid. So this is effectively a multisig. And so since we require both those two signatures, only one signature of one private key is not enough. So of course, in order to run this script, we need to first fund it. So we run npm run fund, this time with the other script exported. And yes, we get our script funded. This transaction of funding should never really fail as long as we sign with the private key requested or to spend the input ETH2. Because in reality, if you notice, we are not including the native script source anywhere in this transaction. In fact, there are only a given set of purposes that we can use when we can use a script, both native script and plu-ts script. And those purposes are only maybe spending UTXOs, as we are doing here, minting new assets, managing staking credentials, etc. But we do not, and this is really important, some people make confusion, we do not call a contract when we send funds to the contract. The contract only runs, so the source code only runs once we spend in our case. But we do not have a way to include the running of a contract in the same transaction where we receive funds, unless, of course, we are at the same time performing some kind of other action in the same transaction when we receive. So as an example, we can have some input from us and then an additional input from the contract itself. And in that case, the contract is pending that input, so it has access to the transaction and it can run if we are. Of course, though, the key difference is that in that case, it's running because it's pending something on its own. So let's check that we got this transaction on chain. And yes, we have it on chain. So that means that we have now some funds on this script that is different. If you notice, we have a different address and we have a different script hash. So now we can go back and run npm run spend to spend also from this script. We should expect this transaction to fail because, yes, in fact, this transaction does fail because we have not modified the spend script. If you remember, this script requires us to sign with two private keys, but we are signing only with one. So let me go ahead and add another signature. And of course, with a different private key, we need to sign with private key number 1. And now, if you remember, yes, this is the source. So we require two signatures of different private. Of course, I know what are both the private key because I have derived the address from those. So these are the two private keys. And now that I'm signing with both, I'm respecting the rules that this multisig script is imposing on the transaction. So if we now run this spend.ts that we are signing with both the private keys, here we should see the transaction succeed. And in fact, we do see that we submitted the transaction over here. We also see that we have two signatures here of our two keys, and we see that native script, of course, that is imposing the additional rule. So we go here and we see that the transaction was accepted. So everything looked good. Last but not least, I want to change once again the script that we are using to use this after origin. if you notice, this script does not impose any use of signature. So we can take this script and export it as script so that we do not have to change the source of the other two. But this time, we will remove both the signature of the spending. So before spending, of course, we need to fund. So we run npm run fund with this new script exported after origin. And we go here, yes. And the transaction for funding, of course, was accepted. This is nothing exciting at this point. We have seen this many times. We will just wait for the transaction to be included in a block. So give it a second. Yes, and it made to the blockchain. So now the blockchain is aware that the script does have some funds and we can try to spend. Now remember, we are using this script, very simple script, after slot 0, and we are trying to spend from that script. You notice here. So if we try to run, not fund. We won't run npm run fund. We see that the transaction failed, but this time the reason of the failure is not because we have not signed, but because we are messing with the time. Now, one very important thing of Cardano transaction is that transactions are deterministic. In order to be deterministic, though, we need to specify all the information that are relevant to the transaction being validated before submitted. If you notice, in this transaction, we have no information regarding the time, but we are specifying a condition that requires knowledge of some time. So this is just nuances at this point, but it will turn really an important detail when we see plu-ts script. But in order for the node to check that we are actually after the slot 0, we need to add an additional field to our built-in that is invalid after. And here we specify a slot of the blockchain. We can just use 1 here because we know, of course, that we are after slot 1. Slot 0 is the origin, very origin of the blockchain. Of course, the blockchain is running, so slot 1 is passed for sure. So here, the core difference is that we are specifying some time to which this transaction is valid. So wait, not invalid after, but invalid before. Okay, so invalid before 0, invalid before 1. So starting from slot 1, we can submit this transaction, and we are not signing this transaction. If you notice, there is no signing here. We have only the script. So we can try now to spend that we have specified invalid before, and we see that the transaction makes it to the blockchain, but there are no signatures. There is only the native script. So this is to demonstrate you that we do not really need to sign a transaction if we are only spending from or using the script, because the script does work as a signature on its own in some way. And so we see that in this transaction we have an input from the script and an output going back to our own address. We have some fee, and yes, we have an additional field that is validity interval star that is necessary for this native script to be valid. If we click here, we once again see that the blockchain accepted this. So this is our very first use of very simple script, and in the next video we will try instead to use somewhat more complicated plu-ts script, which are instead Turing complete, so much more powerful.